presentation. Oh my, I take up a lot of space. But yes. So as you see the course outline, you're seeing a little bit of number theory here. Then they turn their attention to a bit of algebra. I will say a bit for the rest. Most of the course, right? Most of the course is algebra, right? Then a little bit, I think the person who prepared it kind of got mixed up because I'm seeing statistics on the relation function and graph. Something seemed wrong with it, right? Um, something a little odd. But I'll take this whole statistics part and put it down at the bottom here, right? So I don't know why I'll put a test in the middle of matrices, and I do everything on matrices and then have a test, right? Um, I'll have to rearrange things here. Order, the order isn't so well thought out, you know? Yeah. Um, are you still seeing the course outline?
Yes, sir.
Yes, sir.
Okay. Yeah, just let me know if what you're seeing on your screen. The reason why I have two screens, right? I don't have one screen, I have two screens. So sometimes I'm a little uncertain as to what you're seeing. Right? Good. So let's spend some time talking about number theory, right? Let's talk about number theory. Let me pause. Stop sharing that screen. Share back the whiteboard. Now tell me if you're seeing the whiteboard.
Yes, sir.
You're seeing the whiteboard. Great. Right? Good. So as a little introduction, right? Oh, by the way, y'all are seeing the notes on the Moodle page. I put up some notes there. I know when you read the heading, you might be a little puzzled. As a matter of fact, I am teaching a course on algebra in at UG Bordeaux. And basically the course is the same thing, right? This whole part about number theory and algebra and so, it's the same thing we're doing here, right? So I just use the notes. So I know you read the heading, it's going to say MTH 1101. So don't worry about that. It's the same material, right? You're at UG, IDC is just a branch of UG, right? That's why some of you will transition straight into some programs right at UG, right? And what we're trying to do is fill that gap. So when you come, you are prepared, right? Yeah. So those notes start to talk about sets of numbers, right? Sets
Charge up.
of numbers. I haven't written a long time on the graphics part, so my handwriting is not of the best. I think that's a lost art these days, being able to write neatly. Everybody's typing, everybody's texting, people hardly write. Right? But there are some professions where handwriting is still valued, you know. So don't let go of that skill. If you have nice handwriting, from time to time, practice it. Practice it. I'm horrible at writing. It's a real struggle for me to write. Good. So you've heard of sets of numbers. Maybe if you went to high school, if you went to any other institution. Could you tell me of some that you know? You tell me any set of numbers that you know.
Natural numbers.
Okay, somebody says natural numbers. Great. Natural
Whole
numbers.
numbers.
Okay, I didn't get that one. Okay, wait, let's not go away yet. All right, save your thought. Somebody suggested a second one. Let's talk about this one a little. What's this really? What are natural numbers? Any thoughts? What are natural numbers? Anybody remember? Nobody remember what are natural numbers? I'll tell you what.
Counting number, sir.
Okay, great. Somebody said, yeah, I've heard that before. They call it counting numbers. Yeah. And what do you mean, right? How do you naturally count? You count what? You usually go 1, 2, 3. And now you go, you don't go 0, right? You don't say 0, 1, 2, 3. You don't say it. You normally say 1, 2, 3, right? You naturally come from 1, right? I'm not certain of the history of why they give it that name, right? If that's the idea, the thought behind it. Mathematics history is a very under-researched area, right? A lot of it you get from stories only, right? As a matter of fact, we're going to talk about this thing about how they count from 1 going on, right? And because of that mistake, right? I don't know if you know the story that there was a mistake about when Jesus was born, right? In that they thought there was a 0 year, right? But really and truly they were wrong, right? And therefore, because the present calendar we have, we end up well, when we do the calculations on it, right? Jesus ended up being born 1 year before our common era, right? That's why you don't hear 1 year before Christ, because it sounds ridiculous. How can Christ or how can Jesus be born 1 year before Christ? Right? And that's why you're hearing people don't say that anymore. We don't use BC. We say BCE, right? That means before our common era, right? Jesus was born 1 BCE, right? So yeah, it's funny, right? How that whole thing happened, right? Um, I just want to pause this recording. I have an important call. Just 1 second, right? Yeah. So yeah, I think the simple reason why they call him that is that's how you naturally call, right? Uh, and I think
Sir,
they're
can you turn up the volume on your end so we can hear you better, please?
all right, let me see. Let me know if I wanted this fan. I have a fan near me. Whether that's disturbing thing. And that's the little symbol there. Sometimes you see a little double N, on the end here. How do I sound there? Better?
Yes, sir.
Yes, sir, I can hear you. Sir, yes.
Okay, good. Yeah. So somebody was suggesting, oh, by the way, we started off with this and we're saying that, okay, this set of numbers is the numbers 1, 2, 3, going on and on and on and on to infinity, right? It doesn't stop. So that's a set of natural numbers, right? Somebody was suggesting another one. Somebody
Whole
was
numbers.
suggesting. Which one?
Sir, even numbers?
Somebody was saying even.
Whole numbers.
All right. Somebody said even. All right. I'll entertain this one. All right. Even numbers. Yeah. Right. So what are these? What are these?
2, 4, 6, 8, 10.
Okay. Yes. Yes. Those are the numbers. All right. 2, 4, 6,
Sir,
8.
even number can be divided by 1 on itself?
You sure about that? One. Well, every number is divided by 1 on itself. Think about it. But look at these 2, 4, 6, 8, 10. Besides 1 and itself, what else can they all be divided by?
2.
Even numbers. Even numbers are numbers that can be divided without any remainders leave behind.
Divided by what? think you're missing
Divided by 2.
Divided equally.
divided by 2. But there's something missing from the definition. Even numbers are actually, you can either say they're natural numbers that are divisible by 2. Right? And I'm happy that we're going all over the place with the sets of numbers, right? Because somebody said whole numbers, and that's a natural thing the teacher will tell you in school. But I'm going to entertain any order. The reason why is that you are at the level where you're supposed to be able to, see the relationship, between these sets of numbers, right? Between an amount, right? So they are a subset. Even numbers are a subset of natural numbers, right? Even though the number, 0 is divisible by 2, that is 0 divided by 2 is 0. The bigger set, so if the bigger set is not whole numbers, right? So even numbers is not, while yes, it is a subset of whole numbers, right? It is a subset of whole numbers, but the definition, so that's important, right? When you talk about these sets of numbers, because these sets of numbers form the basis, right, of much of the mathematics that we're going to deal with, right? And the algebra, the arithmetic, and so on. It's good for us to get very clearly the definition, right? Because remember, these are, there's a debate about whether these numbers, they were there all the time and people discovered them, or whether we invented the whole thing, right? But in the context of this discussion, right? When we looked at all the numbers and so on, talking about mathematicians, they made sure that they defined them in such a way that as we proceed deeper into the mathematics, the definition doesn't violate, other rules and so that they have, right? So even though, yes, all even numbers are whole numbers, but there is a 0 out here, right? So it's in the whole numbers, but it's not even, right? Not even. So a subset, sorry, let me move this aside. Yeah. So, the set of natural numbers, if we were to put the even numbers in here, there's nothing, the 0 is not out here, right? You have numbers like 1, then there's 2, right? And there's 3 here, then there's 4, and so on. But the number 0 is not out there, right? So keep that in mind, that an even number has to be natural, right? It's a natural number, right? We do not say that we are, it's you can say it, but people who would, insist on the rules, right, will say, don't say that even numbers are whole numbers. That, you understand? You can say it, but those who, are very picky about, the rules of mathematics and how things are defined, they might find fault with that, right? Keep that in mind. Right? This whole thing about number theory, as a matter of fact, some people spend their lives studying, right? So we're just touching on the tip of the iceberg, right? Okay, so we talked about natural numbers, all right? Numbers, we talked about even numbers. Okay, just now that we touched on even numbers, there's a general formula for even numbers, right? The general formula for an even number, right, is 2n, right? Where n is an element of capital N, right? That's what I'm talking about definition, right? So 2n, right? The general formula, the general form of an even number is 2n, where n is a natural number, right? And therefore, if you want to generate any even number, you just substitute a natural number there, right? You substitute 1, you get 2 by 1. That's an even number. You substitute 5, 2 by 5, you get 10. That's a even number, you know? And it's the reason why I'm telling you that the definition of even numbers is based on the fact that this n here must be an element of the natural number. Right? That's interesting. And that's why some people say, if you were to define it for somebody, and you say that even numbers are whole numbers that are divisible by 2, right? They'll find a lot of fault here because, as I just told you, 0 is divisible by 2, right? 0 divided by 2 is 0. You put that in your calculator, and you'll see that it's so. And this will kind of violate, right? Or kind of go contrary to the definition because 0 is not an even number, right? The input, you know when you all do functions before, the input or the domain, I'm getting into some really advanced words. The domain of even numbers is not whole numbers. It's the set of natural numbers, right? I remember when I was a young boy and doing mathematics and stuff, teacher correct me, old guy, right? And there were those who would say, man, 0 is divisible by 2, therefore it should be even. And the older guy, who was an old math teacher from Skeldon side, he said, no, get this straight. The domain in this formula 2n, right? The domain n can only be a natural number. It can't be a whole number. Sorry, it can't be any whole number because somebody would throw in 0 here, right? It can be some whole numbers like 1, 2, and 5 and so on. But if you just say it's the set of whole numbers, somebody would quickly say it could be 0. And you have 2 by 0 is 0. And that's an even number? No. Right? So those are the little, what would I say, peculiarities of these definitions that you must know, right? Most of the time, right? Students, I know, I taught high school, right? I've taught first form, I teach this thing, they forget it, right? I should say you forget it. Second form, teacher teach you again, you forget it, right? Third form, you teach it again, right? You forget it. Fourth form, you teach them again, they forget it. And when they write CXC, the question come on it, they forget it again. People always forget them. But what I'm going to use most of the mathematics we're doing, and I think I should have talked about this, as to why we're doing all this algebra, is to get you thinking, right? If the purpose of teaching algebra, I think I should have discussed this at first, is to develop what we call cognitive processes, right? And cognitive processes got to do with, how you think, how you think, right? And you're seeing those numbers that we were talking about there, and so being able to recognize relationship, right, between and among the sets of numbers. If you can develop your ability, to understand these relationships, right, and how you can picture them, like, okay, I think you will take all of these numbers, okay, we start with natural numbers in there. Then around natural numbers, got whole numbers. I leave the even business out. Then there's a set of numbers called I think they call them integers. And got Z, right? And then around that, There's another one called rational numbers. And I think they go with Q, no? Right? So all of this is like in a big set, right? In a big set. And outside here, there's what we call irrational numbers, right? And all of these numbers is in a big universal set called real numbers, right? Real numbers. So you got natural numbers, you got whole numbers, you got integers, you got rational numbers, you got irrational numbers, right? And they all combine to form this big set called real numbers, right? And maybe I can just quickly go talk about, we talk about natural numbers, whole numbers. Well, it's the natural numbers, but you have zero now, right? So whole numbers, take note of file number. So what is the one card? I told students don't call me so late, and so on, right? The difference between whole numbers and natural numbers is that you have a zero, right? And zero is a, if I was to say historically, a new addition to the number system, right? At least this number system we're using. There are many, oh gosh, it's forcing or not. Give me a second, let me just, hi, look, hello? Yeah. If you read the note, you will see I said make a special effort to come to that class. The class is online, right? You have to read carefully. Your university students, right? Now it's nighttime, I did another class. Yeah, yeah, you have to be. Yeah. We'll meet you tomorrow. I met them yesterday. I said, man, I have a life outside of UG. You have 8 hours a day. Don't call me nighttime. Call me nighttime. Whole day you call me at nighttime too. No, can't do it. Yeah. So whole numbers got this extra addition. I was telling you that historically, zero is it's like a new addition, right? Relatively new addition to the our number system, right? As a matter of fact, though, I must tell you that zero has been, or the concept, the idea of nothingness, right? To describe when there is nothing, was present in a lot of other cultures, a lot of civilizations, and so on, right? And I just want to highlight, maybe Sir told you this story already, like the Aborigines, they would have like a little stone to mean zero, and a little, stick to be one, or the Mayans, and so some of them will use a little a rounded stone to be zero, and a piece of bone maybe to be one. This idea of a zero is seen in a lot of civilization, right? There's that debate among the Indians, right? Indians and the Arabs as to who really had a number system with zero inside for it, right? I'm not going to get into that argument, right? Because the Arabs say the zero is there. The Indians are saying Arabs used to go do trading in the Indus Valley, and they saw them counting with zero, as part of their number system, and they brought it back to Africa and all of that. I'm not going to get into that, because how do we prove who it really belongs to? I'm debating it, but I don't see how it benefits me. But you all probably know that when they did the Roman numerals, right? There was no zero. You didn't have a zero, right? Well, remember the Roman numerals start from 1, and then an I, I think there's a 2i for 2 and so on. I don't know them quite well. But the concept or the idea of zero and being able to represent nothingness or nothing, zero, was present in some civilization, right? And it's interesting, yeah, that this idea of 0 and 1, right? 0 and 1. I tell people this, people say, mathematics is they teach you a lot of unnecessary things and so. But have you thrown away the mathematics that involve 0 and 1? Now you would know that computers, right? Computers, they represent everything in computers with zeros and ones, right? Every single thing in this world, up to a color, the color red has a certain representation in terms of 0 and 1, right? A word like a letter, you say the letter R-E-D, R has a representation with zeros and ones. E, right, has a representation with 0 and 1. So they built, imagine the computer, the mathematics that govern computing was built on something that the Aborigines and the Mayans and so had all along, right? So when they went and they killed off those people, I mean, luckily for us, they kept the mathematics, right? Today you learn it as binary numbers and all of that, right? The story is interesting how these number systems work and so on, how they become useful as new things were developed, right? It was the simplest way that we could have represented everything. Imagine every single thing in this whole wide world can be represented with a series of zeros and ones, right? And they translate that with what it would mean on a microchip or on a hard disk, right? And today we have all the computers we have. Huh? Okay, yeah. What? So let me go back to this. Yeah, this whole the relationship between on among the various sets of numbers, right? Oh, by the way, the universal set that we're familiar with is R, but there is a bigger universal set, right? That, well, I don't think in this course you will ever be introduced to it, right? You will hear of it. I remember one time I was teaching a class, and one of the students was saying that, okay, you know what, sir? I was asking that if beyond real numbers, whether they think that there are other numbers, right? And I remember a student, not knowing what she was saying, said, well, if these numbers are real, maybe there's something called imaginary numbers. And I'm talking about university students. So they all started laughing. The girl, right? Girl sitting right near to me, and she said it's innocent comment that well, sorry if you're thinking of another set of numbers other than real numbers. Well, what about if we get imaginary numbers? And the entire class started to laugh this girl. So I tried to calm them down, and I said, you know what? As crazy as that song and all of you are laughing, there is a set of numbers called imaginary numbers, right? Imagine, yeah, imaginary numbers, right? And from imaginary numbers, there's something called complex numbers, right? Complex numbers. That is a bigger set there's a bigger set that include all real numbers as well as imaginary numbers. They all were shocked that I said that. That a girl who just said something crazy actually said something that is revolutionary, I told him, I said, that's kind of neat. We laugh every good idea we laugh. Right? We don't have a better one, but we laugh good one. Yeah, you know, I said, no, you almost laugh ideas, right? Ideas need to be analyzed and developed. Don't laugh at a good idea. I mean, bad any idea. Don't laugh at it, right? The other time, all of you probably know of this guy, Elon Musk, and what the work he is doing. Most of the time, people laugh at what Elon talks about. And yet, the man is making it a reality year after year, right? So, yeah, we mustn't do that. Anyway, back to the point I wanted to make about, this, especially the course you're doing, is going to really cause you to do some thinking where your cognitive processing will be involved. As I said, I tell you about the sets of numbers, we talk about it, you remember it for a few days, and then you forget it. However, right, causing you to think and to think about relationships and processes and the order in which you solve, let's say you will talk about equations and so later on, simple equations, simultaneous equations, quadratic. The process that you go about solving those things cause you to develop, as we said, cognitive processes, right? Cognitive processes got to do with step-by-step thinking, logical thinking, right? If we can bring everything down to an algorithm, then we can write computer programs that can do everything for us. That's how AI came about, right? Today, you don't need any of these things you want to know. You want to know what are whole numbers? You type it into an AI. There's no reason you come to this class, right? Type in what are natural numbers? What are integers? What are rational numbers? What are irrational numbers? Right? You don't have to. You don't have to go and come to this class here and talk about them. The AI will tell you it all, right? You could ask the AI, right? You could ask the AI, what is the relationship? Just see what the AI will tell you. Yes. Copy that. You want to see what the AI. I want to paste it into the AI. I wonder why you think they can do that. I'm going to ask it what's the relationship. What is the relationship among the following set of numbers? Let me see what it's going to do. One second. Or they give me a table. Here. They give me a table. I thought they would have given me all right, let me show you what they gave. I'm thinking of how do I make this? Yeah. Can you see this?
Yes, sir.
Yeah.
Yes, sir.
Yeah. They're giving you everything. Look at it. Right? They're giving you everything. Right? I wish. Yeah. Well, they could like somehow this particular AI. This is Bing, right? they're not able to draw the Venn diagram. So they're explaining that natural numbers, right, is contained in whole numbers, right? And the whole numbers are contained in integers. The integers are contained in rational numbers, and they're all contained in real numbers. Yeah. Irrational numbers are also real numbers, but not part of rational numbers, right? So rational, irrational, they both come together to form the real number. Yeah. So the AI can do it for you, right? But you now, you are required to, yeah. Go back to my whiteboard. Yeah, you want to try to see if you can see the relationship, right? You want to see the relationship between these numbers and so, between and among, I should say, these numbers, right? Okay, but just a quickly thing before, you say I never mentioned it. We talk about natural numbers, we talk about whole numbers. The integers basically are whole numbers, right? But the negative ones as well, negative and positive whole numbers, right? So the integers will include, all the -3, -2, -1. But of course, you can go on and on, -4 and so on, right? And then coming over to the positive side, 1, 2, 3, So this way they get greater, that way they get lesser, right? You've heard of the number line, right? You've heard of the number line? You've heard of the number line? Basically, the real numbers, they can all be found on the number line, right? So the here is 0, this way is negative. Yeah, I was muted for a moment there. I know I didn't say nothing. Y'all can hear me again? Y'all can hear me now?
Yes.
Yes, sir.
Yes, sir.
Yes, I think I went offline and for some reason.
Yes, sir.
Yeah, sorry about that. Yeah, so all these numbers, you can actually find a position for them on the number line, right? So you have the natural numbers there, the whole numbers from here. Integers include the negative ones. Rational numbers are basically numbers that can be written as a fraction, right? And all of these can be written as a fraction, right? -3 can be written as -3/1, right? 0 can be written as 0/1, right? But that also includes a half, 1/3, and so, right? Once you can write them, and I think some books would qualify and say, qualify the definition and say exact fraction, right? Exact fraction. So, rational numbers basically are those numbers that you can write as an exact fraction. On the other hand, irrational numbers, right, which is something you see some textbooks use Q with a complement sign outside of rational. I've seen textbooks use the word I too, right? But I like this Q complement because you know that Q complement means everything outside of Q, right? If you're not rational, you are irrational, right? So numbers that can be written as an exact fraction is what you call irrational, right? And we'll talk a lot about them a little later, right? All of you know about pi, right? Pi. right? Pi is sometimes in the text, some of the books they tell you 22/7. This is not an exact value for pi, right? This is not an exact value, you know. So don't take those say 22/7 is pi. It's an exact fraction, no, right? There's another one later on. If you ever study any mathematics, you learn about e, right? That's another number. Then we will talk about this set, a set called surd, right? Like square root of 2, square root of 2, square root of 3, square root of 5. These numbers can't be written as exact fractions, right? And therefore, they're all irrational, right? And I don't want to get into, I mean, you can always read the notes on all the different uh, sets of numbers that you have, right? Um, well, somebody alluded to even numbers. You've heard of odd numbers. You've heard of prime numbers. You've heard of composite numbers, right? Um, here, right? Don't behave as though you're living in the 20th century. Any number you're not certain what it is, you type it into an AI, right? Or you type into the internet, and the internet will define it for you. You're not living under a rock now, right? You're connected to the whole world of knowledge through the internet. So I'm not going to go into a definition for every single one, right? The entire fourth and second week, they're all those numbers that you're talking about, right? You just type them in anywhere and you'll get an exact definition that will work. Right? Most of the time, the AI will give you a authoritative definition, right? They might even give you the reference and all, right? What I want you to know is this kind of relationship here, you see, okay, their relative position on the number line, right? The relative position on the number line, right? And maybe how you can show the relationship between them, right? I didn't want to show you this relationship. I can probably ask you something like this, and you would think, well, how do I connect? How do I show the relationship between and among these numbers, right? This is something that you could have, if I had given you as a little quiz, for you to do, would have been good, right? Because when I show you here, you don't have nothing to think about. And therefore, as the thing says, your cognitive processing will not develop, right? Will not develop if I just tell you every day, right? You sit passively and you just, no, don't do that, right? Read, investigate, right? If you have, I know I'm sending notes to you. I think I made some notes available, right? I think that's a bad thing I do with students. I give them notes and they stop writing. But I don't know if you ever heard this, but when you write notes, right? When you put your pen to paper, memories are formed, right? If you study memory and so you understand it, when you write things down. So even though I have all of it, I have a video of it. I'm showing you all of this here. I'm recording the thing. I'm giving you notes. You feel everything, man. No. But when you make notes, when you write, right? When you listen actively, right? That's what I'm saying. From time to time, unmute. Stop me. Gap a little. I might not know everything. Nobody knows everything. But engage me, right? Let's talk. Don't pass it. I know you might be tired from work and so, but then is when you really push your brain to the limit, right? Make notes. Get a notebook, right? Get a notebook. Put IRM, what it called, 01, 05 or what, and put on a heading as to what topic we discussed and so you wouldn't quickly forget stuff, right? Holding your hand, that's how the way you hold your pencil, you make notes. It helps you to develop memory patterns, right? Helps you to develop memory patterns. And probably that is why I think sometimes in all these When we have tests now, right? Like, okay, and let's say it's a written test, and take students to the classroom and give them a test, they remember nothing. That's sort of know you talk about a thing, okay, remember nothing. Why? Because they were sitting down and just listen passively. They have the recording, they have the notes, and that's it. But no, you get a book out, you write some notes, you know, and there must be something that is not in the notes, right? That you can write down. You don't have to watch a whole hour recording just to get this little bit. You must take out a little nugget out of the whole class that you would choose to remember, right? Jot it down. Yeah. So let me put this whole thing copy here. So yeah. So I think we yeah. We talked about this is what you were supposed to do firstly, right? Talk about all these sets of numbers, right? Whole numbers, natural numbers, integers, rational numbers, irrational numbers, and they're all in this big, for now, I'll call this the universal set, the real number, right? But as I said, if you were to ever study mathematics a little more, you'll come to hear of imaginary and then something called complex numbers. That is even a bigger universal set, right? And well, that's amazing. That opens up so many possibilities, right? Yeah. But maybe we can venture into our second week as well, just to buy some time. I want to send some notes, some more notes on all of you. I think I'll borrow some notes from I'll borrow some notes from you know that book Raymond Tulsi. I think the book name Mathematics, a Complete Course by Raymond Tulsi. I think I'll take some notes from there for you, right? Yeah, so we can look at these. When you talk about powers of numbers, what are we talking about? You must know about that, like if you raise a number to a power. 2 squared, right? Or 2 cubed. What does that mean? It doesn't mean 2 multiplied by 3. No, doesn't. What it means is 2 multiplied by 2 multiplied by 2. Right? And I guess you know that. 2 to the 5th power means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. 1, 2, 3, 4, 5. Yeah. 2 by itself, 5 times. Right? And you speak of factors of number. Factors of number. What you're talking about is numbers or all the numbers that you can that can divide this bigger number. So, like okay, let's take number 16, right? Factors of 16 will be like 1, 2, 4, 8, and 16 itself, right? Right? You wouldn't call 0 a factor. No. Can't divide by 3. As you go on and study higher, I know when you talk of factors of a number, you only think of the positive numbers, but later on, if you were to study mathematics a little later, you'll see that they slacken the definition. And you'll see that when we do something called quadratic, you'll see that we can talk about, you know, -1, -2 being factors of 16, right? As of now, you know, in elementary mathematics, they'll tell you, no, these are not factors of 16, right? But we'll kind of slacken the definition, you know? It's like you're watching TV, your mother and father say, you know, you see people kissing on the TV and say, you don't watch that. That's wrong thing. And when you get big, what happens? Slacken the thing, maybe you're a teenager, you see a boy gets a girl, you giggle and they say, they're watching you. They're watching you and they tell you not to. Right? They slacken the rule a little bit, right? You know, when you little, go, come in this house 6 o'clock. Somebody's scratching up on my whiteboard, yeah. And when you get big and all this, you want to come out till 10 o'clock, man. Your rules change as you get bigger and you get more understanding, right? Same is happening with factors, right? Right? So again, you want a definition, you go online and just type in factors of define the factor of a number. And people tell you, right? Understand? You go in there and our square numbers, numbers that you can and you put on them like in a dot here. Square number is like a nine, Four is a square number, And you arrange them, they can be a nice square, Yeah. You find out what is a prime number. Anybody knows what's a prime number? What you can remember that? You don't know, you just Google it. Google will tell you. But it's good for you to know it, right? You see, again, that is why internet can be a bad thing. It's a good thing you can get answers quick, right? But if you don't use memory, right? If you don't practice your memory and use your memory, and that memory is among one of the cognitive processes we're talking about. If you don't use memory, right? If you can't remember things, you can't see relationships and so, right? So your higher order thinking skills of recognizing patterns and relationships wouldn't be there because you're not remembering nothing. You don't remember any facts, right? You understand? So if you don't remember facts, how will you connect them? You can't just say, you know what, man, you gotta know that the internet gets it. So what are you gonna do with your brain? You plan on selling it? So it will cost more because it's empty? Never use? No. You wanna develop your memory to remember things. You must remember something. And I'll warn you, the studies, well, we haven't had time to do the studies yet. But if you see you don't practice your memory, you see this AI thing and this internet thing where everything we can go and get. So we don't commit nothing to memory anymore. Everything is stored in the cell phone. Everything you put in the cell phone. So your memory is blank. You see when you hit your 50s and so yeah, right? Because what the brain hasn't done any work. Everything the AI is doing, everything the internet is doing, everything the phone is storing and processing for you, And that is why mathematics, algebra, this is our focus. This is our focus. The development of your cognitive processing, right? So yes, yeah, you can Google it quickly, but you must remember what are prime numbers. Anybody remember? I'm sure your teacher told you first form. They tell you the second form. You have to know prime numbers from primary school. Anybody knows? I can understand you don't know about counting.
Yes, sir. I
Sir,
I
a prime
stated it
number
earlier.
is a natural number greater than. Anybody hear me?
Yes, I'm hearing you.
Okay. A prime number is a natural number greater than 1. That is not a product of two smaller natural numbers.
Sir, a prime number only have one divider.
Okay. That's true. That's true. That's true. But I wouldn't tell you, right? Let me not tell you. I don't have to tell you everything. Right? The contract didn't say I have to tell you everything. I do some research. What are prime numbers? Right? As a matter of fact, somebody spoke about even numbers earlier. There is $1 million prize, right? There's something called the Goldbach. The Goldbach conjecture. Is this word a G or a jecture? Sorry. Conjecture, the J. The Goldbach conjecture. Basically, it's telling you that every prime number, I think, is what is it? Is it every even number is a sum? Oh, what does that mean? I'm trying to remember what it is. is it every prime number? Every even number, I think greater than 4, is a sum of two prime numbers, right? Like 6, right? It's 3 and 3, right? 8 is 5 and 3, you know? We go 10. 10 is 5 and 5, you know? Every even number greater than 4 is a, I think even 4 works because 2 and 2, this is prime and that's prime, right? You understand? So, yeah. And there's $1 million price, 1 million US. 1 million US. 1 million US. If you can prove this convention, and it's related to prime numbers and even numbers. Even numbers. Yeah. And nobody, at one time, right now, it's one of the way called the millennium problem. There's 7 millennium problems. And they thought that these problems, they've been around long. Make what? Is it money that make people don't work at them? So they have this prize. Somewhere in America, somebody put up $1 million each, right? If you were to solve any of these problems. And one of them was solved. One was solved. The other 6 has not been solved. This is one of them, right? Yeah, it's an interesting sum. Yeah. Then we talk about prime factors. Prime factors, because once you know about prime numbers, right? There's something called prime factors. Let me see if I can erase something here. This might erase. Erase something. Somebody mark up the screen and now I can't remove it. Let me go to. Good. So coming back to, yeah, prime factors of a number. You will know that every number can be written as a product of their prime factors, you know, like let's say 6, you know, well, one, you can start from 1. 1 is 1 by 1. These are not prime, but they don't consider 1 as a prime. 2 is equal to 2 by 1. 3 is 3 by 1, you know. 4 is 2 by 2. These are prime. That's jump. 5 is 5 by 1. 6 is 2 by 3. This is prime, that's prime. Every number can be written as a product of their prime factor, right? Of course, the prime numbers themselves, like 7, 5, and so. You'll say 7 by 1, right? Even though, again, by definition, they say 1 is not prime, but we can waive that rule for the sake of these, right? So let me say every non-prime number then, right? Every non-prime number can be written as a product of prime factors, right? Keep that in mind. Yeah. All know what are multiples of numbers. Yeah, multiples of number, like, okay, multiples of 2, multiples of 2, what do we mean? Well, 2 by any natural number, right? 2n, right? So 2 by 1 will give you 2, 2 by 2 will give you 4, 2 by 3 will give you 6, and so on, right? Multiples of 3 will be 3, 6, 9, right? So it's multiples of 3n. 3 times 1 gives you 3. 3 times 2 gives you 6. 3 times 3 gives you 9, and so on. That's what they mean, right? By multiples of numbers. Then there's something, and this one is important. We will need this a lot. These two. I'll leave them for a little later, right? A little later, because they're very important when it comes to factorization. You hear about, I'll leave that, right? Factorization, right? And when we deal with fraction, right? then we'll need lowest common factor. I guess you all know about that. LCM, right? You hear about that. And HCF, right? Highest common factor. Leave these two for next week, right? Send some notes and so for you to read, and then we'll get into those two a little bit, right? So we basically covered about 2 weeks of work there, and please read the notes and so, right? Read the notes and have a notebook where you jot down stuff, right? Important formulas and so, because even though your test, I mean, it's open book basically, you would, I have to find out how they run the test. I think it's not open book. I have to actually do that test, right? So, yeah, make notes, right? That when you see you're ready to revise, not all your notes is useful, right? I'm talking about the notes I sent you. It might be plenty of pages, right? You need to go through all of that, would be too much, but you make notes with your hand, right? It develops memory, right? And the main points of what we talk about can stand out, right? Good. So we covered quite a bit of ground there today. What we do is stop there. Let's see my stop this card.